Hi, welcome back to the science of COVID-19. In this video, I want to discuss some of the studies that have been done about how COVID-19 is transmitted. So, in this study, the researchers looked at what happens when somebody coughs. And they essentially used some laser illumination technology to look at everything that comes out of somebody's mouth when they cough. It's kind of amazing to think that we can't see most of this when somebody coughs, but it's all there. And what they discovered is that when somebody coughs, there are two sizes of droplets that come out. There are these large droplets that are between 100 and 1,000 micrometers in diameter, so up to a millimeter in diameter. And then there are these smaller droplets that are up to about, let's say, 10 micrometers in diameter. When you just talk, you have smaller droplets produced that are, again, between 1 and 10 micrometers in diameter. So the reason this is important is that coronavirus has been thought to be transmitted not only in these large droplets, but also in these small droplets, which means that even when you talk, if you're infected, there is the possibility of releasing coronavirus into the air where it can be breathed in by somebody else, resulting in an infection in that person. Now, the researchers also then measured the speed of these droplets and how long these droplets stay in the air. So for these large droplets, between 100 and 1,000 microns in diameter, they can shoot across the room at up to 23 feet per second. So you cough, and a particularly fast droplet can go all the way across the room within a second. These large droplets, though, because of the effect of gravity, they don't stay in the air very long, and they fall to the ground within a second or so. The small droplets that occur both when you cough and when you talk, though, stay in the air for much longer. They, in these experiments, took 9 minutes to reach the ground where they could no longer be breathed in by somebody else. So imagine this scenario. You're infected, you're asymptomatic, so you don't know that you're infected, and you're not wearing a mask. You go into a store and you buy something, you say, thanks a lot to the cashier, have a great day, I'll see you later, you walk out. Now, 2 or 3 minutes later, somebody else comes in. They also are not wearing a mask, and they're in that same space talking to the cashier. It's possible that that person could be breathing in the same droplets that you just expelled when you were talking to the cashier 2 or 3 minutes earlier. And this is why it's really important to be conscious of wearing masks, because even speaking from asymptomatic individuals can result in transmission of the virus. These researchers also looked at how the airflow within a room affects how long these droplets are in the air. So in a room with no ventilation, so a completely closed room, these droplets take about, more than, I should say here, more than a half an hour to gradually go down to the ground where they can no longer be breathed in. In a room with poor ventilation, meaning just mechanical airflow, it's a little bit shorter. So it takes, let's say, around 13 minutes to completely fall to the ground for all the droplets to go down. And finally, in a room with good ventilation, so this means some mechanical ventilation, and then you open a door, you open a window, it goes away pretty rapidly within 5 minutes because of the greater amount of airflow. This is why being outside is associated with really reduced transmission, because there's a lot of airflow outside, and these droplets don't stay in the same area for a long time. They, are dispersed, their concentration decreases, so somebody around is not going to be breathing in a lot of infected droplets. This is also a reason why there's a lot of concern about increase in coronavirus cases as we head into the winter months, because with the cold, more people are going to be spending time indoors. Interestingly, and luckily for us, in this study, they found that with normal breathing, so just through your nose, not very forceful, no droplets are detected above the background noise level. So you're not really, in general, transmitting infected droplets just by breathing through your nose. This table is now from another study. And again, they measured how many aerosol or droplets and aerosols, which are very, very tiny droplets, you can think of it as that, how many of these droplets and aerosols are generated with different types of activity. So again, these researchers confirmed the previous study that normal breathing has really none to very few droplets. A single strong nasal expiration, so, right, that can release more, a few hundred, up to a few hundred. Talking or counting loudly can again be a few hundred. A single cough with your mouth open, a few hundred, up to a single cough with mouth initially closed is up to many thousand, surprisingly. And my guess is that that's because when you cough with your mouth open, you don't have as much pressure inside to release. Whereas if you're trying to suppress your cough, that tension builds up. And then when you finally release it, the droplets are expelled with much greater force. And interestingly, a single sneeze can release up to a few million droplets. Okay, so that is really one of the one of the biggest releases is sneezing, and that is actually shown in this next slide. So here, these images are compiled from experiments that were done measuring the quantity of droplets that were released with these different activities and how far they went in meters. So the bottom lines here are meters from 0 to 8 meters. And you can just see visually that if an infected person coughs, or sorry, if an infected person sneezes, there are a lot of both large droplets and smaller aerosols that are released. And these aerosols can travel quite far. The amount of droplets and aerosols released is a little bit less with coughing, as we saw it in the table before. And for an infected person, even exhaling, okay, is associated with some expulsion of droplets because this expulsion, you can imagine that if you're infected, perhaps you're breathing more forcefully, or it's harder to breathe. So you have to have more force to, get the air in and out. And this can then release more droplets. This is a really interesting experiment in which they were able to simulate what happens in a small space like a car. And I believe this is with the windows open even. So you can see that there's some airflow going in and out of the windows, but here's an infected person in the back seat without a mask and then with a mask. And without a mask, you can see almost everybody here is getting exposed to a lot of droplets and aerosols. With a surgical mask, it is less, but there is still quite a bit of exposure to these uninfected companions around this infected person. And I think this sort of experiment just underscores the importance of not only wearing masks, but social distancing, because masks, of course, will not stop all droplets and aerosols, especially if the person is infected and might be sneezing, coughing, or breathing more forcefully. So I think that these data that I presented really show the importance of following some of these mask recommendations. And obviously the chance of transmission for two people without social distancing and without wearing masks, even if somebody's asymptomatic, is quite high. This reduces with wearing masks and social distancing. I want to end this video by talking about asymptomatic infection. So we've talked a lot about how asymptomatic infection can cause transmission of the virus. And this study, early study done from China, can I think demonstrate the importance of paying attention to asymptomatic infections. I should say that it's significant that this study was done in China, because here they were able to measure the amount of virus inside both symptomatic and asymptomatic individuals. And this is because when they identified symptomatic individuals in the population, they had a broad testing program and they tested everybody. So they were able to catch individuals that were asymptomatic but were still infected. Unfortunately, we don't have this kind of data from the United States because testing in general has been done from symptomatic individuals. So the left side and the right side are two different tests, PCR tests, that are used to monitor how much viral concentration there is inside these people's noses. So these were taken from nasopharyngeal swabs. Each group has 37 individuals. The blue is asymptomatic individuals and pink are symptomatic. And the way that this test is done, the higher the number here on the y-axis, the lower the concentration of virus in that person's nasopharyngeal swab. And likewise, the lower the number here, the higher the concentration. So let's take a look at this test on the left here, because I think it illustrates the concept nicely. If I were to not tell you which group was which, who blue represented and who pink represented, you could see that these are almost identical within the margin of experimental error, right? You couldn't say with confidence which group is which. And in fact, there are some asymptomatic individuals that have viral concentrations much higher than some symptomatic individuals. So I think there are 2 points to be noted here. One is just because somebody is asymptomatic does not mean that their viral concentration in their body is lower. They could have the same risk of transmitting this infection as somebody who is symptomatic. Now, the caveat here is that somebody who's symptomatic is probably going to be coughing and sneezing, so they're going to be releasing more particles. But still, because the particles can be released even with talking, there is a chance that somebody who's asymptomatic with a high viral load can transmit the infection to the people that they're around. The second important point here is that because the viral concentrations in asymptomatic and symptomatic individuals are on average the same, or at least within the same range, it really raises the question of why, if the concentration of virus is similar, are these people symptomatic and these people asymptomatic? This is sort of, to use a cliche, the $1 million question right now, or one of them within COVID-19 research. And I think that this supports the hypothesis that it's about how our immune systems respond to this virus that might determine how symptomatic we are. So in some people's cases, the immune system might not mount a huge response. They can clear it, or let me put it this way, they can clear the virus without causing a lot of damage to our own bodies. And in other people's cases, the activation of the immune system results in a lot of symptoms and potentially damage to our body. So I think this is one of the questions that scientists are really eager to answer. There are efforts now for scientists to collect genetic samples from both symptomatic and asymptomatic individuals across the world to try to have some insight into why it is that some people react very violently to this infection and others don't. Thanks so much. I'll see you next time.